Hello, physics fam. We are doing a math skills overview worksheet. So feel free to follow along. We're going to do some practice problems together in case you could use the support. First question we're going to do is that we have 25 miles that we want to eventually convert into meters. If we look above though, the only conversion I have is miles to kilometers. So is it possible for this one to convert from miles to kilometers, and then once I get kilometers, I could convert to meters? Remember with the metric system, King Harold died by drinking chocolate milk. So could we use the metric system for the second step to go from kilometers to meters? I think so, totally. So let's go ahead and do that. Remember, for any type of problem where we're going to do conversions, let's make sure we always write down the number we have, the number we're given. So we have 25 miles. I'm going to put MI for short for there. Now I want to get rid of miles, so I'm going to put that in the denominator to cancel those out. The conversion factor I have right up here, right? Kilometers to miles. So I'm going to put kilometers on top. With kilometers on top, I know then that's going to convert. Get rid of miles and go to kilometers. So I know I'm going to put 1 kilometer per 0.62 miles. I'm just going to put the number that's next to the proper unit. When I do that, we already know that miles will cancel out. So you got rid of the units of miles, which is great. And now you're in kilometers. So what I'm going to do is I'm going to actually calculate that. Once I get that answer, I'm then going to use my metric system conversion, which remember is just moving the decimal point. So it's kind of like two problems in one here. So keep an open mind with it, no worries. But when I do 25 miles divided by 0.62, I end up with about 40.32 kilometers. Now, remember, I want to get to meters. So if I'm going to go from kilometers to meters, and again, remember, easy mistake, this M in the metric system is not meters, it's milli. Your meters is actually at the base, right? Meters, liters, seconds, grams, those are all base units. So to go from kilo to meters, or base, you're gonna have to go 1, 2, 3 to the right. So you're gonna move your decimal point, 1, 2, 3 to the right, which means you're going to still use all those numbers, but you went 1 decimal place past. So you're going to add a 0, right? 1, 2, 3. So it's going to be 40,320. And since we converted 2 meters, that unit is going to be meters. So it was a 2-step problem. It was a good one, though. And hopefully you were able to follow along and that made some sense. Checking out number 2, we want to go from 33 hours to seconds. Now notice there's no conversion factors up on top for hours to seconds, but I do expect you guys to know that, right, for every 1 hour, there is 60 minutes. And then we also know that for every 1 minute, there is 60 seconds. Or like some of you have already done, maybe in the class for another problem, we know that there's 3,600 seconds in 1 minute. So think about which conversion factor you'd like to use. You could go from hours to minutes and then minutes to seconds. Or since we know there's 3,600 seconds in and forgive me, I shouldn't have said 1 minute. Hopefully you guys caught that. I meant 3,600 seconds per hour. So make sure you caught that. Sorry about that. All right, let's go ahead and do it. I'm going to switch colors here. I'm going to do 33 hours. I want to get rid of hours and into seconds. Why? Because that's what it asked me to convert to, hours to seconds. I know for every 1 hour, there's 3,600 seconds. Now quick check. Why is hours on the bottom? Because our units have to cancel so that you're left with seconds up on top. So what I'm going to do, 33 times 3,600 divided by 1. We always multiply by the top, divide by the bottom. What I end up getting for that is about 118,800 seconds, which is a lot of seconds. But there you go. Quick little conversion using dimensional analysis, using units to cancel out. Taking a look at number 3, you have 4.5 feet and you need to get to centimeters. So when I'm looking at my conversion factors, first of all, I know that there's 12 inches in a foot, but that's inches. I need to get to centimeters. And look at this, inches to centimeters. So it looks like I'm going to need to go from feet to inches and then inches to centimeters. So let's go ahead and do that. I've got 4.5 feet. I'm going to use this conversion factor to first get it into inches. So I'm going to put feet on the bottom to cancel and inches on top. Now that I use my units and knowing that feet are going to cancel, I know that I can put 12 inches on top for every 1 foot. I just got that from my conversion factor. And let's keep the party going. Double check, does feet cancel? It does, that's great. So now technically I'm in inches. I've converted to inches, but I want to get rid of inches and I want to go to centimeters. So let's do that. I'm going to get rid of inches. I'm going to go to centimeters, and according to my conversion factor, for every 1 inch, there's 2.54 centimeters. Double check my work. Inches cancel. I'm left with centimeters on top, which is exactly what I wanted. So now let's do our math. Remember, you type in the first number in your calculator, multiply by 12, divide by 1, multiply by 2.54, divide by 1. Remember, you always multiply by the top, divide by the bottom. Throw that all into your calculator, and you should get about 137.16 centimeters. So looking over all of that, that was a 1-2-step problem because you went from feet to inches and then inches to centimeters. Hopefully that made sense. If not, don't be shy. Make sure you bring specific questions to class. That really helps. And you can say, hey, I struggle with the 2-step problems. I do the first step and then I don't know what to do next. That's a great specific question. It's a great way for people to help you. All right, what are we on? 5? We're on number 4. Sorry, we're on number 4. We're going from 5 milliseconds to seconds. Take a look at that. MS, milliseconds, that's a metric unit, and seconds is a base unit. Remember that under the base unit is seconds, grams, liters, or meters. Those are all considered base units. So really you're going from milliseconds to the base unit seconds. So this actually becomes a really quick problem. We love the metric system. Go from milli to base is 1, 2, 3 to the left. So that's what I'm going to do with my decimal point. 1, 2, 3 to the left, which means I'm going to have to add 2 zeros. So my decimal point's there. I have 2 zeros. Then I'll keep the 5 and 0. It's no longer milliseconds because you converted it seconds. And then, of course, you can always throw the 0 in front too. But because it's a metric system equation, perfect. We just need to move the decimal points. Hopefully that was straightforward. Make sure you know your metric system. King Harold died by drinking chocolate milk. Kilo, hecta, deca, base, deci, centi, milli. All right, good job. All right, next one, number 5, is also a metric system. We've got 1.5 kilometers. I want to go to millimeters. So notice they're both meters, kilometers and millimeters. Kilo is right here. Milli is over there. So I'm going to switch my colors to make sure we can follow, but here we go. 1, 2, 3, 4, 5, 6 to the right. So I'm going to take my number. I'm going to go 1, 2, 3, 4, 5, 6 to the right. Remember, at the end of that 6 is a decimal point. So now we're going to add in our zeros for every loop. There's my decimal point. And I could throw a 0 after if I want. Technically, we could learn something called sig figs. You don't always want to write the 0 after that. But in the end, let's rewrite this whole thing properly. We've got 1, 5, and then you have 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5. And don't forget, it's important. You have to use the units. It's now in millimeters. So look at that. If you run 1.5 kilometers, you're actually running 1,500,000 millimeters. And we used our metric system to do that really quickly. Hopefully that made sense. If not, ask a question in class. Sorry about the next one, number 6. It talks about sig figs, which actually we're not covering in class. So I'm going to skip that one. And hopefully that's skipped on yours as well. If not, feel free to skip it currently. We no longer cover sig figs in academic physics class. So let's go to number 7. I'm going to go and take this 15,060,000 centimeters, and I want to put it in scientific notation. Okay, remember in scientific notation, you have to take the first actual digit that isn't 0, that's all the way to the left. You take that number and you put a decimal point after it, and then you write out all the other numbers up to the non-zero digits. So I'm going to put 1.506. See how those are all the numbers that are non-zeros? Now, I'm going to multiply by 10. And the thing is, I need to figure out how many decimal places I need to move this decimal point so that it would go back to the original number. So if my decimal point's here, I got to go past the 5. 1, 2, 3, 4, 5, 6, 7. So I need to move my decimal place 1, 2, 3, 4, 5, 6, 7 places to get it back from here to what this number used to be. So since I had to move it 7 places to get it back, I would put this as 1.506 times 10 to the 7th centimeters. That is scientific notation. This next section, we're going to be looking into scientific notation. Just remember the form for scientific notation. You always have a number and then a decimal, and then whatever numbers come after. But then it's going to be times 10 to some exponent. So let's try that. We need to put 560 into scientific notation. So what we want to do is take the number all the way to the left, 5, and then put a decimal, and then put the rest of the numbers. Then we want to multiply it times 10 to the something power. The way to figure out the exponent for that, remember, is if I put the decimal point now between the 5 and the 6, it's going to take 2 decimal point moves to get it back to make it 560. So since I had to move it 2 decimal points, I would make that the exponent of 2. So that's what you have to do. You have to turn it into the proper form, a number and then a decimal point with all the other numbers after it. And then you have to figure out what that exponent is going to be. So let's try the next one, and you'll notice it's a smaller number. It's less than 1. So this is actually going to end up being a negative exponent. So let's try it out. The two non-zero numbers are 4 and 8. So I'm going to do 4.8. But if you notice, if you do 4.8, now the decimal actually has to move backwards from 4.8 to get to where it was. So from between 4 and 8, I'm going to go 1, 2, 3 places backwards. So because I have to go 3 places backwards, the way I'd write that in scientific notation is 10 to the negative 3rd power. Negative 3 meaning you have to move your decimal 3 places to the left or backwards to get it back to where it was. Looking at the next one, 43,200. I'm going to take my first number all the way to the left that I have, put a decimal point, and then the other non-zero numbers, 4.32. Okay, you could leave the zeros off if you want currently. There are rules to that with something called significant figures, but right now we're not too worried about it. But you could leave the zeros if you want. Otherwise, I'm going to multiply times 10 to something power. Remember, I have to figure out, if I now put my decimal point between the 4 and the 3, how many places do I have to move that decimal to get it back to where it was? Well, 1, 2, 3, 4. So I'd have to move it 4 places to the right, so I would use a positive 4. Positive exponents move the decimal place to the right. Negative exponents move the decimal to the left. So that's a good rule to remember. Let's look at the next one. You've got 4,320,000. I'm going to use 4.32 again. Notice it's similar to this one, only the exponent's going to be different. Letter C was times 10 to the 4th. This one, let's figure it out. In fact, I'm going to make my pen a little bit thinner, so hopefully I can write a little bit better for you. Let's do it between the 4 and the 3. We got 1, 2, 3, 4, 5, 6. I think I counted that right. 1, 2, 3, 4, 5, 6. Yep, that is 6. So because you would have to move the decimal 6 places to the right, we're going to make that a positive 6. Let's look at letter E. You've got all these numbers, 0.00065. We need to take the non-zero furthest to the left in the number, put a decimal point after it, and the other numbers afterwards. Follow along. Now notice that the zeros are behind, so we're going to have to work backwards. You put a decimal point between the 6 and the 5. So let's work backwards. 1, 2, 3, 4 backwards means I would make this a negative 4. Cool? All right, let's try letter F. 101.35. This is a good one because you're going to make it 1.0135. And we've been getting used to like moving the decimal point all the way to the end, but in this case, it's not at the end. You have it after the first one, but you only need to get it back to after the second one, between the 1 and the 3. So that means you really don't have to move your decimal point 1, 2 places. So that means since it's 2 to the right to get it back to where it was, you would use the exponent 2. Okay, that's a little scientific notation recap. We will use big and small numbers throughout physics, so being able to write in scientific notation and also put them properly in your calculator will be a really valuable skill. All right, nice job with following along with that. Let's jump next to making unit conversions. We are on to our final section of this page, which is just metric conversions. Remember, the King Harold died by drinking chocolate milk. Don't forget your base units. That's often seconds, grams, liters, and meters. It'll be other things too, but those are the more common ones that you guys are probably used to right now. Let's do it. I've got 35 millimeters. I want to get it to meters. Remember, millimeters is milli and meters is base. So you've got to move it 1, 2, 3 to the left. So now that we moved it 3 to the left, let's write our number. Here's 35. Remember, if there's no decimal point, it's to the right. Let's move it 1, 2, 3 places to the left. So that means you're going to have to add another 0 and put it there. So let's clean that up. Your number is going to be 0.035 meters. All right, we got that first one. Let's do the next one. 450 centimeters. Centimeters to millimeters. Centi is right here, milli is here. So to go from centi to milli is just 1 decimal place to the right. So if you have 450, assume that that decimal is to the right. You're just going to need to move it 1 more place. So that means it's going to be 4,500 millimeters for that one. Nice, I like that. Let's look at the next one. The next one is 250 kilometers. You want to go to centimeters. Okay, so kilo to centi. Kilos here, centis here. 1, 2, 3, 4, 5 to the right. So if I have 250, I can assume the decimal's at the end of the number. So I'm going to move 1, 2, 3, 4, 5 to the right. So that's it. 1, 2, 3, 4, 5 zeros added. So let's clean this up then. So I've got my 250 and I added 5 zeros. 1, 2, 3, 4, 5, and I put my label centimeters. So that becomes 25 million centimeters is 250 kilometers. Wow, that's quite a bit. Quite the difference. Perfect, we got that one done. Let's go to letter D. Here we go with letter D, 1,500 milligrams to grams. Remember, grams is a base unit. So we can go from milli to regular grams to base. 1, 2, 3 to the left. So if I take my 1,500, assume that my decimal's to the right. If there's no decimal, I'm going to move 1, 2, 3 to the left. It looks like my decimal point is going to come between the 1 and the 5. So it's 1.5 grams for that one. Not too bad. Let's look at the next one. 346 ms is milliseconds, 2 seconds. All right, we're in milli, And don't forget, seconds is a base unit. So once again, it's 1, 2, 3 to the left. So I have 346. I can assume the decimals at the end. Go 1, 2, 3 to the left. So it's going to be 0.346 seconds for that one. And let's finish off strong. Milligrams to kilograms. Let me get a new color here. Milli to kilo. Woo! 1, 2, 3, 4, 5, 6 to the left. Let's take 543. 1, 2, 3, 4, 5, 6 to the left. Wow. Ends up being 0.000543 kilograms. See how quick that starts to go once you get the hang of it? But now you've had a review of not only the metric system, but scientific notation and also conversions with dimensional analysis. I hope this rings a lot of bells and is making you feel more confident. Remember, the reason we want to be solid with our math skills is when we learn new theory in physics, we don't want the math to hold us back. We want the math to supplement and help support the ideas. Proud of you guys. Keep up the good work, and I'll see you in class. Make sure you ask specific questions. Be well.